calculus lesson on 7.2a, trigonometric integrals. Today's one will focus on sine x and cosine of x. Before we begin though, the whole underlying idea today is to utilize sine squared x, cosine squared x equal to 1, the Pythagoras relationship between sine and cosine. As you could see, this is even, so which means that I could write that as what? That could be written as 1 minus sine squared x. And if you're wondering, well, if it's odd, we can't do that, right? Well, that's exactly the beauty of this technique. If you have an odd power, one of the things you could do is sine of 2x, let me just zoom that in a little bit, and cosine 2x, pull out onto the outside. And this feels like this should be du, doesn't it? Right? Then my u had to be cosine of x, right? That means that du is what? Negative sine x dx. Hold on. If that's the case, then negative should come over here, and this expression becomes negative du. And that feels like this should be u squared. And you know that that could be 1 minus cosine squared x, then that's 1 minus u squared, isn't it? Right, so that's the whole technique. And for this one, you could probably write that as cosine to the 6x times cosine of x dx, and that becomes du. Then u must be sine of x, right? Then that's equal to cosine of x dx. That's exactly what it was. All right, you might want to try to pause this video and see if you could get it done on your own. All right? Okay. Here it goes. So when it's odd, when either sine or cosine of x is odd, you should be thinking about doing this, guys. Okay. So the work that comes with it looks something like this. So you see me do this up until this point, right? And once we replace this, I pull out the negative on the outside, and the expression becomes 1 minus u squared times u squared. We distribute that. Here we go. The antiderivative. And then we replace all the u's with cosine of x. And there you go. That was the entire key to this. Okay. All right. Now let's try that with the next question, right? So when this is cosine of x, right, we do the same exact thing, right? And here we go. So we did pull it out, and that tells me that then u must be sine of x, because the derivative of that gives you cosine of x dx. So I say to myself, okay, then that must be du, and I took the extra time to pull it over here. Going forward, I suppose you could just do this really quickly. Once you get in the habit of doing this, I would just go straight here, right? So that's a 1 minus sine squared x, which is what? 1 minus u squared. So we got this. As you could tell, I was reminding myself of the coefficients of the binomial expansion, right? Just be really careful about this, guys, okay? And if you don't remember this, make sure you go ahead and review, or make sure you come to the office hour. We could go over it. And then when I expanded it out very carefully, because it's minus sign, we know that it's plus minus plus minus. Just be really careful. And then once you get to this point, and go through all the pre-calculus, algebra, and trig stuff from previous year, we could expand it out, and then we do the math, the stuff that we've done all year, right? This part, we did the antiderivative, and the u, you replace that with sine of x. So the only thing that we're learning today is really, when you say something odd, make it even by pulling one out and treat that as du. All right, guys? Now, if you look down over here, this table tells you that exactly, okay? But I think it's better to look at the table after you've done it intuitively a few times, and this kind of summarizes it, right? Yeah, so trying this out on your own is no replacement for just memorizing the table. Now, what do I do over here? Well, I said if it's odd, you could pull one of the trigs out, right? So which one do I take out? Well, it's your choice. See what happens. All right. When I do the first one, I pulled out, in this case, sine of x, right? Look what happens. Okay. I got sine of x dx. And that tells me my u must be cosine of x, negative du sine x dx. And that right there is u cubed, but because this is an even power, because I pulled it out, I can express that as 1 minus cosine squared using Pythagoras relationship. And that's 1 minus u squared. Distribute. And this expression becomes this right here. I distribute it, antiderivative, and I be sure to distribute the negative afterwards, right? And then replace it, a u equal cosine of x, and there you go. All right. And there are those of you who must have already done it trying the other way around, right? And here is the answer for that one. There you go. Yeah. All right, let's see what that looks like. When I expanded this, I have cosine of x out there, and then that tells me that u must be sine of x. So du is sine x dx, cosine x dx. That's du, that's u cubed. That must be 1 minus sine squared, so it must be 1 minus u squared. So I did all the substitution over here. So this is a new technique for today. That's all it is. And the rest is this. What is the antiderivative of this once you expand that out? And then we substitute that u's with sine of x, and this is what we end up with. And you're looking at this and you're going like, hey, wait a minute, they look completely different. Are they the same, really? Are they really different? If you're thinking, well, the first thought I had as a student was, well, we take the derivative of this and the derivative of this. They're equal to this. Great, done. But that wasn't really satisfactory to me, right? And then if you sort of think about this, right, because they're all even power, isn't it? So what I could do is use the Pythagoras relationship, right, and show that they're the same. Look what happened, right? Using the trigonometric Pythagoras relationship, theorem, or identity. So I have this. Let me zoom in. So that is cosine squared squared. That's cosine squared to the cube. But cosine squared is 1 minus sine squared. When you expand it out and rearrange them, this is what it is. It's the same. And you could go either direction using trigonometric Pythagorean theorem / identity / property. Okie dokie. All right, guys. So here's the next question. What if this is an even power? Well, whenever it says half angle formula, guys, read power reducing formula. And let me do a quick review. It's going to be really fast. Okay? Now, going back to last year, you should know that the angle sum of the cosine is equal to this. But what if they're both alphas? It's 2 alpha. Then that becomes an alpha, that becomes an alpha. That's cosine squared, sine squared. Check. If I replace this with its Pythagoras equivalence, which is what? 1 minus cosine squared, it becomes this. If I replace this with 1 minus sine squared, it becomes this. So now we have this relationship. Let's solve for cosine of 2x. Sorry, cosine squared x. And then square root both sides. That's what I get. Wait a minute. But x is half of 2x. So with small substitution, I just arrived at a half angle formula. Do you remember this derivation, guys? Yeah. But if you go back a couple of steps and look over here, and same thing with this expression right, guys, right? Solve for this sine squared x. This is an intermediate step to proving the half angle formula, or showing the half angle formula. But this is what's known as the power reducing formula. So when we say, give you a hint of half angle formula, we're also implying power reducing formula. We don't know how, sometimes we don't know how to do the antiderivative of this expression, but we do know how to do this, right? That was the whole point. Now, in case you don't remember, right, you just need to remember this one. And if you forgot, what if we take that as a u? then du is a times dx. Then 1 over a du is dx. This expression becomes what? Cosine of u du 1 over a. It becomes that, right? Yeah, just too much going on here, so I'm going to just erase this. Oopsie. There you go. So you should just do this on your own just to show that this is true. Okay? All right. We're going to be using this so often, you should just know this. Just know it cold. Okay? The other thing that I want to point out was this one right here, guys, right? So sine 2x double angle formula is equal to this. So when you have this, we've done this in the past, right? We could have taken either sine or cosine as a u, and we got this expression before, right? But if I replace this with the 1 minus sine squared x, I end up with this, which is negative half plus c is c, because negative half is a specific constant plus general constant is still a constant, right? So that's why this expression is the same. So we've done it before, so today's lesson sort of expanded on that. But the variation on this one, as some of you did in your homework in the past, is if I put 1/2 times 2, that's 1, isn't it? So that's what I did. So I could use the double angle formula. When I do that, antiderivative is equal to this. Boom, we're done. Right here. And then you could check that they're the same as these two simply by using double angle formula in either one of them. And we end up with something that's very similar. Once again, whether it's a c or quarter plus c, it's still a constant. The whole expression is a constant. Okie dokie. All right, guys. So that's a nice memory trip back to previous material. Here it is. So what do? Well, let me grab what I already wrote out for you guys. Here we go. Sorry about that. And look at this. There you go. So I'm going to write this as a cosine squared right there. And we know that in power reducing formula, cosine squared of x is 1 plus 2x, everything divided by 2. I expanded that, and I end up with this. And I have another square. So I do it again. So it's 1 plus cosine of twice whatever that is, which is 4x divided by 2. Now, once that happens, I substitute that right there, right? I expand that out. And ultimately from here, this is where you want to go. So the key points I'm looking at, to make sure that you use the power reducing formula to go from here to here. And 1/4 plus 1/8 is 3/8. Antiderivative is 3/8 x. And we've done this already, right? Substitute it in, the antiderivative that is. And then when you manage your coefficients carefully, we're done. Okay, guys, that is it. Okay, I'll see you in the class. Okay, have a good night.